we have the seismic line issue, but it's the cumulative effects of many other things. So I think the seismic lines are the low-hanging fruit and are the things we're concentrating on. But I'm not so confident that alone would so-called save caribou.
Oh, interesting. Okay.
It's because of these other issues we've talked about, A being a relic, and seismic lines itself aren't necessarily boosting the numbers of white-tailed deer, things like that. It's surrounding uplands of forest harvesting, fires, other things, the complexity, less snow, especially the winter, less snow. All those things are kind of interacting, the cumulative effects of those that kind of create the perfect storm on caribou, and then we go after the seismic line. Well, we probably should.
To point to the big bad corporation,
and it's the easiest one to do because it's a non-permanent footprint, as compared to a road or a active well pad or that kind of thing. So, it's the right thing to do, but it probably isn't going to solve everything in the long term.
Hey guys, what's happening? Welcome to Your Forest. I'm Matthew Christoph. On this podcast, we talk about the environment and the science of sustainability. That's the catchphrase I've been going with lately, so I'm going to stick with it. It's really just a forum for people to exchange ideas, come on, talk about their work. What we're talking about here doesn't reflect the opinions of the sponsors or anything like that. We're just talking about what we do and what we love. Today's episode, I had the privilege of having Dr. Scott Nielsen on again. I had him on previously talking about grizzly research, and he is the Associate Professor of Conservation Biology in the Department of Renewable Resources at the University of Alberta. He also founded the Applied Conservation Ecology Lab, which looks into all kinds of different things around biodiversity, conservation, everything from insects to grizzly bears. And one group of projects, I guess, that he's been working on is caribou restoration program. So looking into the issues regarding caribou habitat and the reduction in caribou populations in our working landscape, especially with regards to seismic lines. And they're one of the problems that are being focused on heavily. And the thought is that if we can restore a lot of these seismic lines, we can reduce a lot of the issues that come with predation on caribou from wolves and that kind of stuff. So we'll explain all the details and provide a lot of context at the beginning here, so don't worry. That was what we talked about. Basically, how can we restore seismic lines so that we can have more opportunity for successful caribou populations that are sustainable over time and don't require constant wolf calls and all kinds of stuff like that. So it was very, very good. He's got all kinds of information on it. Where can the restoration be focused? Where is it successful? Where do we not need to? All kinds of stuff like that. It was really, really good. So I appreciated Scott coming on. It was awesome. Really good. Always great to talk to Scott. We got a little philosophical near the end there, talking about, what is conservation really? Who gets to decide what these baselines are and these goals? And it was awesome. Really, really fun. So you guys will like it a lot. Lots of good information. Sponsors for 2020. is West Fraser is the number one sponsor for 2020. They are providing funding through the Forest Resource Improvement Association of Alberta, and I couldn't be more thankful for their support. It's really important to me. Thank you, guys. Also, Greenlink Forestry is another sponsor. They've been with me since the beginning, and they're doing great work in the forest industry as well. Again, couldn't thank them enough for their support. Wouldn't be possible without them. And Damaged Timber is also a supporter of the podcast. They support environmental sciences through the sale of the stuff that they sell. 10% of everything they sell goes towards a scholarship for environmental sciences, and you guys can hook that up by checking them out. They got hats and toques, and looking into some other new stuff coming up soon too. So make sure to keep up to date. Anyways, that's about it. And without any further messing around, let's get into it, talking about restoring caribou habitat on seismic lines in northern Alberta with Dr. Scott Nielsen. Here we go. Yeah, I thought a good way to start would just be to set the scene here. So, caribou are hurting.
Yep, absolutely.
What's the deal? Let's start with that, just to try to set the context for the whole conversation here, right?
Sure. So woodland caribou populations in the boreal forests of Alberta have declined, especially over the last 50 years. And the primary issue is that, first of all, their fecundity, their reproductive rate is pretty low. So age of first reproduction for cows are about 2.5 years. So she has to be about 2.5 years old before giving birth to a single calf per year on average, even a little bit less than that some years without calves. And you compare that to, let's say, white-tailed deer. She can have fawns at 1.5 years and 2 fawns per year.
Yeah.
So not only is age of first reproduction sooner, but 2 times as many calves, in this case fawns, for white-tailed deer. So they naturally have very low fecundity or production. And they're pretty sensitive to predation. So
they're goofy animals.
Yeah, exactly. They're goofy animals. They live in an environment that a lot of other things don't live in, these large peatland complexes, at least in the Alberta part of the Boreal Plains. In eastern Canada, there can be more in the Canadian Shield and so on. But around here, these Boreal Plains are pretty unproductive in the peatlands themselves. They generally have not had a lot of other ungulate species like moose, deer, and especially they didn't have deer, and as many wolves, the main predator of deer and moose. But over the years, with climate change, winter conditions that don't limit white-tailed deer, and
so less snow kind of.
Yeah, less snowpack. The snowpack in particular for deer are problematic. Really deep snows and cold conditions, but especially those deep snows will dramatically limit white-tailed deer numbers in the north. But over the last 50 years, those whitetail populations have expanded north up through Fort McMurray, when historically, if you went back to the 1920s, for instance, there were no whitetail deer in Fort McMurray area.
There's mostly mule deer and that kind of stuff, right?
Well, not even that so much. It was moose. It was moose.
Just moose.
It was moose in the uplands for the most part. Yeah, you get some in the peatlands, but the peatlands were primarily the caribou, and up on top of the plateaus like the Birch Mountains and so on. Those areas also had caribou populations.
You go back further than that, it's probably mostly bison too.
And the bison were in the uplands as well. And so there was another ungulate in there. But over these last 50, 75 years, the whitetail numbers have increased to the north. Moose numbers have, they've kind of varied through time, depending on hunting and populations and use and so on. But with disturbance, early cereal environments, forests with either fire, but especially human activity, have increased the vegetation that actually promotes white-tailed deer,
right?
And for the most part, also moose.
Right.
So you get both of those, and you get the predator of moose and deer, which is wolves. And probably historically, the wolves being trapped and hunted, and they were. Prior to the 1980s, 1970s, we were trying to essentially extirpate wolves.
Yeah.
And so there was a lot of pressure on the wolves. Yeah, exactly. So they were reducing those numbers tremendously through trapping and hunting. And anytime they saw wolves, they were killing wolves. So at the same time, there were probably people keeping the wolf numbers down.
Right.
But by, heading to the 1990s, there was a bit of a shift in people, the hides for wolves probably weren't worth as much for trapping and so on. And we've seen those wolf numbers kind of rebound.
Yeah.
At the same time, these other ungulates, moose, and especially white-tailed deer numbers have increased. That has dramatically increased the wolf numbers. And the wolf numbers, although the wolves aren't the primary predator of caribou, it's kind of considered a parent competition, they call it in ecology, which is the white-tailed deer and the moose aren't directly competing with caribou. They use different habitats. But the predator of white-tailed deer and moose will start taking caribou.
Yeah.
So there's this indirect kind of effect of the predator on caribou. And the biggest issue, one of the issues, is that seismic lines, these little narrow corridors cut for energy exploration to map bitumen depth and so on, they're corridors for movement of organisms. And although caribou avoid them for the most part, wolves will use them in the winter as corridors, and that increases their hunting efficiency or access to caribou range in these peatlands. And
it's insane, actually. Like anecdotally, I can speak as like a hunter walking around. Like I'll be hunting moose in a section, and it'll be the whole piece will be quartered off by cut lines or whatever.
Yeah,
right?
exactly.
And every cut line around this piece, I'll know there's a moose in this chunk of bush. And every line has wolf tracks going around it because they're doing the same thing I'm doing. They're circling, waiting to see where it's going to come out, and they're going to follow it. And it's like I remember I noticed that when I was about 16, and I was like, "This is wild."
Yeah.
Like, they're intelligent creatures.
Yeah, I was just going to say they're smart, right? They want to be efficient, and probably one of the most efficient ways of doing it is walking down a corridor, a cut line.
You just put on the miles, right?
Yeah, you can put on the miles, and the more miles you put on, the more chance you're going to intercept your game.
Yeah.
That's either crossing it for a scent or using it as well, especially in the winter if there was snowmobile use or other wildlife using the cut line, then it's a game trail, right? And it just becomes much easier. So, and that in itself, well, you wouldn't think, well, what's the problem? Well, again, it kind of comes back to the fecundity issue of low reproductive rates of caribou. So though the wolf predation isn't substantial, it's enough to become problematic when you only have one calf a year,
right?
And it takes a while, 2.5 years to reach maturity or have your first calf.
Yeah,
that's a problem. So
they just don't get a break from.
Yeah, they don't get a break, and some people would say, well, that's the primary issue. The secondary issue is we do have a little bit more wildfires and so on going on, as people know, and any early cereal habitat is kind of considered non-caribou habitat, right. Particularly because in the winter their primary forage is lichens. In our region, ground lichens, the reindeer moss or reindeer lichens. And those take about 40 years to recover after a wildfire. Yeah. So some people would say, roughly if there is a recent disturbance, that's non-habitat for caribou for 40 years. And historically, it didn't matter because caribou ranged over fairly large areas. So you have a wildfire here, it doesn't matter. They'll shift over somewhere else. Yeah. It's this shifting mosaic. And over time, the wildfires after 40 years actually can be pretty good because you actually can get even a little bit more lichen in that 40 to 60 to 80-year-old range. Okay. And sometimes if the forest grows a little bit too old, gets too mature, you actually decrease lichen biomass. Oh. So at the broader scale, having a few wildfires is good. Right. For sure. But it's not very ideal for the fact that it promotes deer and moose and wolves. Yeah. And maybe some of these wildfires are a little bit bigger than they historically were. Well, it's a weird problem because it's kind of a runaway issue, right? Like I think if we, like you said, like we previous to like fire suppression and that, fires would have been normal, but they would have been relatively small scale for the most part. Obviously, large fires happen, but for the most part, and they would have gone through regularly, and you would have had. So they would have had options. Yeah. So now with fire suppression, we have this like powder keg where when we do get a fire, it blows out the whole area, and now they have no habitat, whereas before they would have had other areas to go to. And so, it makes sense. Exactly. We need that. The shifting mosaic can be helpful, but at a much smaller scale than the most recent fires like the Richardson or the Fort McMurray fire that were big. And I guess we would mention that even the Fort McMurray fire, that was in May. Yeah. And traditionally, although First Nations, there's indigenous prescribed burns, and those have been much smaller, less so in the most recent kind of number of decades. But historically, wildfires, the ignition source would have been lightning, and that typically didn't happen until later in June to July, and those fires would have always been much smaller in size. But now we have the incident of, let's say, an ATV, muffler, or sparks or something will start a fire in May, right at that time before before green up of the aspen, for instance, which basically shuts down the extremely large fires because you get these essentially asbestos forests, people call them, kind of these, it's very difficult to burn in green. I never thought about that. That totally makes sense, though. The actual ignition source. Ignition sources are human now for the biggest fires that happen in that phase of we get drier winters, an early spring, and then for whatever reason we're tending to get these spring May conditions, kind of like in Edmonton where we get 30-degree days. Yeah, things haven't greened up yet. It sets up the stage for this 2 to 3 week window if a fire does start. And it's windy as hell. And it tends to be windy. Yeah, like you say, it blows up. Yeah. And without that couple-week period, without an ignition source, we typically don't have lightning in May. We have lightning in the midsummer and mid-June all the way through July and sometimes August. Well, it's that late June, July would have been historically the natural fire regime. Those have been way smaller,
after
patchy
things have
fires.
greened up, it's less likely to explode and become a real problem.
Exactly. So we have the early cereal habitat as an issue. So young forests through any disturbance, it could be wildfire, could be forest harvest, or these linear exploratory disturbances.
Yeah.
And the linear exploratory disturbances are problematic because not only they add a little bit of this early cereal conditions, but like I was explaining before, they increase the movement and predator efficiency for wolves. The last part of the story, which doesn't get quite as much attention, is
it's not as fun as wolves.
is black bears.
Oh, okay.
So, and grizzly bears in the western part of the province, where they overlap some of the caribou range. So, a bear is not going to typically take down an adult caribou at all, especially a black bear. But the bears can be pretty efficient, some bears, at going after calves.
Oh, yeah, for
and so it's the 1 to maybe 3 weeks, but especially that first 2 weeks, that there's a window that it doesn't matter if it's a moose, white-tailed deer, or caribou, the black bears are going to go after these calves. And that part of it, we probably have the least amount of information on what is the actual predation rate.
Right.
But other studies, such as in Quebec, have shown that in some places, black bears can be as big a predator of caribou as wolves. And the wolves tend to be a little bit more efficient in the winter on a variety of caribou, including adults and so on. But if you have this source of additional mortality on calves from black bears, maybe a few wolves, but especially black bears, and you're getting the increased predation rate in the winter and other times of the year on the caribou, it's a double whammy kind of thing.
Yeah.
So it's difficult to be a caribou right now in northern Alberta, where there's a lot of disturbances and predators.
Do you think is there like a similar issue like last time we were talking about the linear disturbances caused a lot of problems for like grizzly bears because of just human access, getting hit by cars or whatever, hunting, poaching, blah 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 blah. Is there a similar problem with caribou, or is it less so because they're not as abundant of a species or whatever?
Well, grizzly bears aren't very abundant either, and it's a very low rate of mortality, but the populations are so small. So in one sense, it's kind of a similar scenario that the caribou numbers are low. So anything that, a few animals being removed from that population is a big issue.
Gotcha.
So if it is, it's less to do with humans here, but it has a similar story of access actually increasing the efficiency for the predator.
Okay.
It's just grizzly bears had no natural predator. It's now us. So we become the linear features create access to get in and bump into grizzly bears.
Yeah.
Well, for caribou, it's the natural predators that are more likely to bump into caribou now.
Right, that makes sense. Yeah. Okay, cool. So we have this problem of seismic lines and grading. So if you think if we didn't have the seismic lines, do you think the moose and the white-tailed deer wouldn't be? I mean, obviously you can't know, but I'm saying, is that the assumption that we think that if we didn't have those seismic lines, that maybe they wouldn't have gone as far north into the caribou area?
Well, I don't think so. I mean, I think seismic lines are the easy target to go after as far as questions on restoration and what to do with. But for instance, the white-tailed deer numbers had made it to Fort McMurray by, I believe, about the 1950s, before there was a lot of linear exploration. But there were some roads that were, popped up to Fort McMurray, the first highway by that time. Yeah. And there was starting to be the start of forestry.
Right.
So it was maybe at that time, the white-tailed deer numbers weren't very large, and they really didn't explode until the last couple of decades, let's say 70s or 80s, when there had a lot more forest harvesting and maybe a little bit better winter conditions.
So it's pretty strong evidence to suggest that the reason that the moose and deer population exploded up there is because of human interaction and exploration and forestry and other. Okay.
Exactly. And moose numbers, I mean, they varied over time. I wouldn't say they've exploded so much, but the whitetail numbers just on top of the natural moose numbers have just made it so it's a lot easier to be a wolf.
It's a hell of especially in a time,
especially in a time when you're not being persecuted by every person out there trying to get rid of a wolf.
Yeah, that's true.
Which probably 30 years ago there were when someone was in the bush, they if there was a wolf they would try to take it, right? So I think that there's a combination of these factors, and so the expansion of those wolf numbers have to deal with their prey, like more white-tailed deer, and then on top of the moose, and the fact that, we're not, it isn't 30, 40 years ago when they were considered vermin and anybody took the opportunity to take a wolf out.
Yeah, people think they think twice now. I think more about I think the general public, as well as like outdoors people and stuff like that, they're thinking about like, oh yeah, I could shoot that wolf. It'd be cool to have a wolf mounted, and it's not like it's illegal to shoot them.
Yeah, no, it's not.
And it's but also I think people think more about the ecology of it. It's like, do I need to? Do I need one? Like, is this something that I'm doing to try and? Am I really being a conservationist here, or am I just doing it because I think it's cool to have a wolf hide or whatever?
Yeah, you're probably not going to eat the meat. Elk or moose or something. So
I don't know if many people nowadays. I know those old timers, like the old fur trappers and stuff during the late 1800s. They would eat wolf meat, but I think that was more out of necessity.
And they wanted the hide anyway.
But, well, that too. And I think it was more out of necessity than it was like, oh, I love wolf meat, but who knows? Who knows? But I don't think we're eating a whole lot of those nowadays.
Yeah, so I do think that's part of the part of it, the overkill. So there was overkill on wolves for quite a period in that bought caribou time.
Yeah,
and some people also say, well, caribou are they're relics. I mean, they're kind of historically they went down to northern Minnesota, northern Wisconsin, northern upper Michigan. So they were down into the northern part of the U.S. Rockies. So even knowing that they were in the Midwestern United States by 1800, and they were one of the first species to be extirpated from Wisconsin and so on very quickly. They were, they're at the southern fringe, and now they're up in the Boreal a little bit further.
It was just recently, like a couple years ago, that the last quote unquote caribou in the United States was killed or something like that. Right? It was a ranging caribou. It had been in like southern BC, and it would spend some time down in the States, and then it got killed or something. It was a collared one, I think.
I think it's the Selkirk population in that region. The mountain caribou in British Columbia and the northern Rockies, U.S. are in serious condition too. I mean, populations of like 20, 15, 5, 50 in a big population. And how
does that relate to? This is off topic. But how does that relate to like what we would think of as historic numbers? Like I would think that caribou wouldn't want to be in huge numbers in the bush. Yeah. You know what I mean?
Well, exactly. I don't think they ever really were. Right. So that is true. They always had these lower densities. And maybe these mountain populations were always kind of little, we even refer to as metapopulations, small populations that sometimes they might have naturally went extinct or locally extirpated. Yeah. But over decades or centuries, they could have been recolonized by dispersing animals and reestablished those small habitat patches. And in the mountains, they're generally foraging in the winter on these tree lichens because the snowpack is so deep that you can't get to the ground lichens, and B, it puts you up in the tree branches to eat the lichens because the snowpacks are so high. And the mountain populations, kind of a similar story as early cereal kind of forest harvests and stuff, have increased moose and elk and deer numbers, and the wolf numbers in a similar scenario have increased. And when you always were only 100 or 200, and you go over a few decades down to 50 or 25, it doesn't take much to put you on a trajectory towards complete loss or extirpation there.
Yeah, they're a delicate species for sure. I think we know that, and we need to be paying attention to them. Yeah, for sure.
Exactly. So that's the caribou story.
Right. Yeah. So what is it about the seismic lines? So we're here to talk about the restoration, right? So let's get into that. We got 18 minutes of context. Yeah. So what is it about seismic lines that is particularly, we understand why it's a problem for the caribou. What is it about them that is making it difficult? Like for example, like if you were to make a cup lock on an upland mesic site, even if you just left it alone, most of the time it's going to come back on its own. It's not going to stay this giant scar, but we do reforestation on there now, so it's not even, but we reforest it.
Sure.
But seismic lines, that doesn't happen. So once a seismic line has been created, there's no obligation to go back and restore, right?
Yep. There's no reclamation required. Yeah.
There's no reclamation required. And that's, so we have 70 years of history of seismic lines now in this province?
Depending on where you are, probably the oldest are, 50, 60, 70 at oldest, but I mean the majority in the last, couple decades again.
Sure.
These seismic lines, some of them do come back, but that's the big question is a large proportion of them don't.
Yeah.
And we generally think of historically those older seismic lines were created by bulldozers.
Right.
So they put the blade down in the winter because make sure things are frozen so they can go through anything, peatlands or whatever. and they'd bulldoze a bearing, a line on a north-south bearing, and then they do an east-west one, straight shot, maybe every 500 meters apart or a kilometer or two, depending on what they were after, for real kind of broad exploration of the underground energy, let's say in the oil sands for the bitumen. And when they'd find, through the seismic assessment, some resource like the bitumen, they would have to come back with way finer detailed mapping to understand the actual like high definition or high detailed depths and thickness of the bitumen and so on.
Oh, yeah.
So they come back with a higher intensity or density of lines.
And
in the last, and so first you have these traditional or legacy seismic lines. They're kind of dispersed. They're not real high density, but they're really big. And the bulldozer kind of simplified the microtopography. And then we have these kind of
I'll just microtopography simply for people that so just talking about the little. So instead of having what we normally have, which is all kinds of undulations and hummocks and all kinds of little changes in elevation on the line, now you just have this flat, table, and it's just there's not a lot of opportunity for seed germination because everything's homogeneous.
Yep, and you nailed it. So there's the big problem with the regeneration. We think is that loss of hummock, natural hummock hollow pattern in the forest, and especially in the peatlands where you have a high water table.
Yeah.
So now if you simplify that microtopography, remove the hummocks, and you even maybe bladed it a little bit, you pretty much almost reach the water table.
Yeah.
And you can actually convert some of those sites to a wet, sedgy environment, almost standing water in some instances, where you're obviously not going to recruit trees into.
Right. So because the trees that germinate, they're going to be the ones that land on the top of the little hummock, on the top of the hill, which is a few centimeters or a couple inches above the water table, and it has an opportunity to germinate, grow roots, and actually touch the water table eventually.
Exactly.
But by that point, it's actually a tree. Whereas if you remove those hummocks, it's totally just now you're at the water table, and the seed just drowns or whatever. It doesn't have an opportunity to actually,
Yep, absolutely. So even those hummocks can be quite a bit bigger, like a foot or two even. So it can be old trees that have blown down and the old root ball of it and so on, and then the sphagnum grows up over it and provides a fairly large hummocks in those cases. So, and you look at the evidence. So we've done various studies using even remote sensing products like LiDAR, which is these laser active sensors, sends a laser and bounces back, and you can figure out not only the terrain underneath the trees, but also the height of the trees and vegetation.
Yep.
And we've used that to map broad areas of seismic lines to show that, especially these wetter sites, especially those peatlands, they're failing to recover even 50 years post-disturbance. That naturally, as you were saying before, natural regeneration, you just expect a forest to recover next to a forest. Because these lines, even the traditional legacy lines with the bulldozer, they were averaging, let's say, 10 to 12 meters wide. And so there's part of the problem. And then the low impact seismic lines, sometimes called 3D seismic lines, for the third dimension of really trying to map really explicitly that energy reserve, like the bitumen, they'll come back at 100 or 50 meter spacing on both the north, south, and east, west axis of a grid. And these lines are generally done they're done in the winter again, and they're often mulched or hand cut in some instances. And they're not they're called low impact. They're much narrower, only 3 meters generally. And the thought was as well, if you're not kind of blading it, you're probably hopefully not losing the microtopography, the hummock hollow. But it turns out that even those lines, because they're a little bit narrower, they don't get a lot of light. So even if they have it, and if you mulch too much, you put too much mulch on top. And so again, you lack the natural microsites that a tree would need to for a seedling to establish. Having said that, I mean, there's those lines, it depends on the condition. There are some that are coming back, some aren't. And a lot of our work is trying to understand, which ones aren't and which ones are. And the issue is the restoration side of things is, just like in forestry, you'd probably want to look at the microsites and so on. You'd use silviculture. And if you lack mounds or hummocks, you'd create mounds, just like you might mound in a cup block in certain kind of condition to promote tree survival and growth. So in the winter, they'll go out with excavators on these lines, and it costs quite a bit, 12,500 a kilometer on average, some more, some less. And they excavate and try to create, maybe about maybe two for the 3D lines. They'll try to get 2 mounds wide, if that makes sense, of an excavator shovel, and just keep working all the way up kilometers and kilometers. Mm-hmm. And the issue is, if there's hundreds of thousands of kilometers of seismic lines, which there are.
That's what I was going to ask. How much seismic line in the Caribou area is there? Right?
Well, in the Caribou area, I'm not 100% sure, but I do remember one statistic was something like 700,000 kilometers of lines in a part of northern Alberta. So it's massive. So even in Caribou Range, it's still on the order of, let's say 100,000 or more than 100,000, and that's still like more than $1 billion. So if we have limited restoration dollars, the point that we try to make in our research is, well, we certainly would want to prioritize it.
Yeah.
And we know the first priority, if it's a caribou issue, is to do it in Caribou Range.
Right.
But even in Caribou Range, we're finding some places are more problematic than others, where they're coming back and not. And a lot of that does have to do with the microtopography, but there's another part of the story that has to deal with fire.
Right.
And we've been spending quite a bit of time looking at natural recovery post-fire. Mm-hmm. So although the fire itself is going to reduce caribou habitat for up to 40 years, the restoration is going to take quite a while anyway, too.
Yeah.
So we call the wildfires and just natural regeneration, we call it passive restoration. The passive restoration is let it do its own work because it's free, but it takes time.
Right.
And so it's a trade-off. It's a trade-off between the cost of speeding up recovery through active restoration, which is pretty expensive, as I explained, and the trade-off of, does it take the same amount of time? If it does, well, of course you would never want to spend the money.
Yeah.
Does it take a little bit more time, like a decade or two?
Yeah.
The trade-off, maybe it's worth waiting 10 more years, 15 more years if you get the same thing through natural or passive restoration or through wildfires. But if it takes, half a century, 50 years or 100 years, or maybe even longer, because they're just totally these wet sedge environments that without anything done, they'll stay completely open.
Yeah.
Well, then those have to be targeted for restoration.
Right. So that comes into the one paper that you had with the predictive model, where you guys would use LiDAR and you'd come across to try and find where these sites are, the ones that are not regenerating.
Yep.
You're predicted to not be regenerated after about 50 years or so.
Yes,
right?
exactly.
And so you guys had said that it could be up to like 1/3 of the seismic lines in the Caribou Range.
Yeah. Well, the particular area that we worked on, which is south of Fort McMurray, so it was one part of a Caribou Range, but it was representative of the type of habitats you'll find throughout most of the Caribou Range. Okay. So roughly 1/3 of those sites were certainly unlikely to recover in the short, well, even in the moderate term, like 50 years or possibly even longer. So those are the combination of areas where they're really wet and they had that simplification of the microtopography.
Right. Yeah. And those areas, and I guess we should talk a little bit about caribou habitat and that kind of stuff, because we talked about what they eat the lichen and that. But my understanding is they spend most of their time in like kind of the fens and kind of those jack pine adjacent areas. That's where they find most of their lichen. Yeah. Right? So really wet, kind of like medium to very rich wetlands with larch and black spruce and that kind of stuff, and then the jack pine adjacent stands. That's where they spend most of their time. So those rich fens and those rich and medium fens, exactly. Those are the ones that you're talking about. Those are the ones that are having a hard time coming back.
Yeah, exactly. So the fens are the most problematic, and they don't. Some places they don't necessarily have that jack pine upland adjacent to them.
Right.
But they certainly benefit from these little patches of uplands of jack pine that have more of the reindeer lichens, the ground lichens that they use. But those same lichens also occur in some of the older semi-open peatlands.
Right.
So, or these fens and stuff with black spruce and eastern larch. So if you get a little bit of opening in the right type of sphagnum community, you also get this community of lichens that grows through that region. So
that area,
habitats,
like that 1/3 that's not recovering or predicted to not recover, it's not only do we need to do it because it's not going to recover, but that's of particular importance to caribou habitat.
Exactly. It also happens to overlap exactly where caribou have their primary habitat.
Gotcha. Okay. Yeah. I think that's the point I wanted to get across.
Absolutely.
Yeah. Okay. So what are some of the areas that they can that like you guys have figured out? Like one of the papers you said was the jack pine was you could almost, if there was a seismic line going through a jack pine forest and a fire comes through, you can basically just leave that alone completely because the fire has done your work for you.
Yeah,
right.
Absolutely. So what we found in that study is Angela Filicetti, a PhD student, and myself published a paper where we looked at seismic lines north of McClellan Lake in the Richardson fire of 2011. And we went there about 5-6 years after the fire. And there's two things. One, I just give a little context. Yep. Jack pine forests regenerate primarily only after wildfire because they have these serotinous cones. Yeah. Some of the cones will actually open naturally in some trees, but for the most part, 99% of the cones require fire to open. And
really hot sun supposedly.
Yeah, and in lower branches it can kind of open it and stuff like that. But
fire is the main method.
And it also needs some mineral soil. So the fire provides that mineral bare soil for the seed to land in and opens up the cones where you get, billions of seeds throughout the forest. And so what we found is, as context again, you probably don't expect the seismic line naturally to recover unless you have a fire, because you don't have seed rain. And even if the seismic line had been disturbed a little bit with ATVs or whatever, and you have some mineral soil, you're probably not going to get much going on. And sure enough, after the fire, 5-6 years after the Richardson fire, we were finding, first of all, a positive relationship with fire severity. So the higher the fire severity, the higher the density of regeneration of jack pine, because it opened up more of the cones. Right. And even in that area of the Richardson, for people who aren't familiar, the jack pine trees tend to be a little bit spaced out. So even when you have a high intensity fire, it is definitely high intensity and crowns out. Yeah. But it's not quite like you'd see these dramatic footage on the TV or something of a forest just being extraordinarily hot and super thick. Yeah. So it flaring up and it burns. At nighttime it cools down and whimpers through and burns and flares up here or there.
It's not the super fires.
It's not the super fire, but they can be really big because they can just kind of slowly creep and burn on for weeks and weeks. For sure. That's what happened in the Richardson. So with that, even the highest fire severity opened all the cones. You had 100% of the cones open, seeds everywhere. And we found regeneration everywhere was increased, of course, in the forest and in the seismic lines. But what was really interesting is regardless of the fire severity level, the seismic lines consistently had twice as many trees as the forest. Right. So it was, we weren't sure. We expected to see regeneration, including on the seismic lines, but we weren't sure whether we'd see actually a little bit less regeneration because maybe the way the seismic line was or the microsite conditions might have been a little bit different or something, and maybe it didn't quite regenerate quite as well, but it turned out even better. The only issue I see is that in the future, you're going to see these strips of denser trees.
So you have seismic lines, but they're going to be treed.
It's going to be treed,
super dense,
super dense treed seismic lines.
Yeah, that's going to be weird.
In a semi-open jack pine forest, because again, like I was describing that Richardson area, the trees are kind of spaced out. It's beautiful. You can just walk through the forest. And
it is really nice.
It's really nice walking around, but you're going to come up against a seismic line. You have to kind of
weed through it,
kind of thing. So. It just shows that, the fires on one side are going to be problematic from caribou because you're losing their forage lichen for up to 30 to 40 years. But in the long term, if you had enough of these fires kind of burning the landscape, it does your job for you for free.
Yeah, right.
And that's a lot better use of the conservation funds than spending a lot of money on something that may burn 5 years later.
So it might be good to just do some prescribed burning in some of these jack pine.
People have said, it's hard because with the caribou issue, they don't really want any, less fires is better in a landscape that has more fires.
But so it's going to happen, right?
It's going to happen, but that's a bit controversial.
I get it. It's controversial, but it's you know what I mean. It's one of those things where it's listen, the boreal forest burns. So are we going to take advantage of a situation that we can control? We can go in here and do a prescribed burn in a way that we can completely control, or at least minimize the potential loss of caribou habitat, and we can do it in a controlled manner so there is habitat still there. Or are we just going to let the next fire take it out? Because that'll happen.
Exactly.
Eventually. It's just a matter of time.
Even bigger then, so that's true. So we think the wildfire, it's a natural component process of the boreal forest, And it's probably going to recover, especially these upland sites, so like the extremely dry sites that also weren't regenerating well. We had the super wet sites that weren't regenerating, the super dry sites. Now the dry sites, it was because of the jack pine requires fire to open the serotinous cones for seed. The wet sites is because of flooding and the microsite loss. And in between, the mesic sites, like the aspen forest, those are the ones that if you just kept ATVs and snowmobiles and so on off of, they're for the most part, they come back on their own.
Right. To some degree.
To some degree, not always for sure.
Yeah.
But it's definitely the spot that you wouldn't necessarily prioritize as much as the driest and the wettest end of the gradient or spectrum.
Especially considering that the caribou aren't spending a whole lot of time in aspen.
Yeah. Well,
forest,
and then because of that it's not prioritized for restoration because, as you say, it's not even overlapping with caribou habitat. Yeah. So it generally is ignored anyway. But it tends to come back a little bit on its own.
Yeah.
And the other part of the fire story is Angelo Filicetti and myself have just been recently working on a paper where we did the same thing. He went to the Fort McMurray fire to the peatlands and tried to ask the question, well, although the microsite conditions, the microtopography might have been simplified, does the fire in any way increase regeneration of some sites that might have been more marginal, had a little bit of microtopography but weren't coming back, and so on? It probably won't ever come back on these wet sedge sites, but for the most part, we were finding not quite as dramatic as definitely the jack pine or the serotinous cones, but black spruce is semi-serotinous. So after a fire, the cones will open. Some of them will open even without fire, but after fire, especially all of them will open. So you get this seed rain again. And eastern larch have open cones that naturally have this seed rain, but it's cyclical in how abundant those cones are. But after wildfire, we do see some natural recovery of quite a few of the different type of ecosites that are that caribou use. And so the thought is the extremely problematic wet simplified wet sedge areas now, the fires aren't going to do anything to, but other ones that are kind of moderately restricted in regeneration. Fires are actually promoting recovery there as well. But again, like I'd say, it's controversial because it's not like the fire is in the long term will restore caribou habitat, but in up to 40 years, it's removed habitat for lichen, and it's probably increasing deer and moose habitat.
Right. So you have to, but it has to be. See, that's the thing, right? Like you could go through and in those areas where you know what I mean. If a fire comes through, it's gonna come back well. But if a fire doesn't come through, it's not going to. So you could go through and mound the whole thing and plant it. And then a fire comes through next year. Well, and you're like, well, shit.
You just spent $12,500 a kilometer. And a fire goes through. So that's our point. Our point is, and some other folks, some colleagues have been looking at this a little bit too. Is well, then let's look at the probability of wildfire. And then let's not prioritize the areas that overlap with caribou range that are at the conditions that are more likely to burn. Maybe if you wait a little bit, and especially if you end up putting the money into it and it burns anyway, it's not necessarily a total loss, because I would point out that when they do the restoration work, it's almost always includes silviculture. So they're going to plant trees like black spruce, but they first always either rip in a little bit more of the semi-open upland sites, or they mound in all the wetter fens and places like that. So if you have the mounds and a fire comes through, those mounds will just definitely
do well.
They'll do super well.
You'll have these.
You'll probably have a line of trees.
And the rest of it is still coming back.
Because some of the peatlands, even especially the fens, for folks that have spent time in there, you can get some thick forests in there. It can be difficult to walk through, but you can also get these semi-open treed peatlands.
Right.
And so if you get a really thick line of trees on the seismic line post-fire, and then maintain the semi-openness, it'll be kind of the flip of the condition. Instead of an open corridor, it'll be a really thick treed corridor 50 years from now. Kind of thing.
No, that makes sense. Okay. So I guess we should talk a little bit about actual restoration and what is the goal of restoration besides obviously is the goal just we want to reduce travel and visibility, or is it like for example, one example I have is do we necessarily need to have, like, if we're in a black spruce bog, do we necessarily need to have black spruce coming back, or is a thick layer of shrub, which reduces visibility and ease of walking? Because, like, I mean, there's seismic lines out there where you'll be walking down the seismic line and go, like, this is terrible. Like, I'm just going to go 10 feet into the bush, and it's going to be so much easier to walk.
Absolutely.
So those ones, I would assume, stuff like that, probably you're not going to go back through, rip it up, and try to, because it's
exactly.
Although it's not what the adjacent forest is for the purpose of reducing wolf movement and that kind of stuff, and deer and moose movement, you're probably would that be safe to say?
Absolutely. So I think the way we distinguish between functional restoration and the functional restoration, if the primary issue of restoration is caribou, is trying to reduce movements of the predator or increasing the population of the alternate prey of the predator, the moose and deer. And so really thick stands of alder, which are extremely difficult to walk through. People have tried that. I've tried to walk through alder seismic lines. It's extremely nasty. You go into the forest. So
I had to do caribou seismic line restoration plots in alder seismic lines. And I was like, this is so stupid.
So there are these places that instead of coming back as, the adjacent forest tree community, certain shrubs, and especially alder in our experience, come back in certain places, and they're forming a functional restoration of reducing movement on that seismic line. So it's working there.
Sure.
The flip side is people would talk about the ecological restoration rather than functional restoration, and they want in the long term to see what's similar to the adjacent forest.
That makes sense.
So from that standpoint, especially if they are going to invest in the restoration, they're probably not going to definitely target those alder sites, but they'll target the open sites. They're going to try to plant it to what's in the,
Well, if you're going to go through and do it, you got to plant what's there, of course. If you're going to do the restoration, you should plant. I'm not saying you should put alder in there on purpose.
Exactly.
But if the alder's there, do you think it would be wise to just kind of leave the places that have alder?
Mostly because the total kilometers of restoration needed are so substantial. It would be very low on the list for a priority kind of thing, right?
Right, yeah.
The only catch is this is a real problem because when they're designing the restoration projects, it's interesting because there's little chunks that need it and little chunks that don't. But the excavator has to get to those little chunks, so they actually destroy some of the natural regeneration in order to get to the patches that need the treatment. So it's this really weird, it's a landscape scale question of how much total linear needs restoration on that line, and is it worth kind of disturbing the natural stuff coming back to get to that. So it's kind of an interesting situation. So, but yeah, for sure, if you have this alder, those kind of things, it's a lower priority. And it also goes to what other people are experimenting with. If ultimately we're trying to reduce wolf movement and access to caribou range, some people have said, well, let's do line blocking. And the line blocking would be someone, if the excavator is out there, they actually pull down mature trees from the adjacent forest, especially if it's a narrow seismic line, like only a 3 or 4 meter wide seismic line. They start ripping trees down across. So it's just if you were faced with a whole bunch of trees just crisscross and everything else, you're like, nah, no thanks. Go somewhere else. So they're experimenting with that. Sometimes at the same time they're mounding.
Just to intercept while we're talking about this. What kind of impact, is there any research being done on the impact of that on caribou movement? Because I would assume that, like, if the caribou would also, they're going to have the same, the wolves are going to have an easier time going through that stuff than the caribou are. So is that negatively impacting caribou migration and movement?
Well, it turns out that some of the initial research on caribou telemetry with the GPS collars on caribou, and they'd watch what they do, they tended to try to avoid the seismic lines anyway.
Oh, I see. Okay.
So then the thought is it doesn't really matter. But having said that, if you start treating everywhere, caribou still has to cross the seismic line. And there are instances where they use them. But from a habitat selection standpoint, like what's the probability of them using it? They're less likely to use it than the undisturbed forest.
It's not going to impact it as much, you think?
Not as much. Right. So it'll impact more the wolves is the thought.
I guess the negative impact from the wolves on the caribou population far outweighs the small negative impact on the
that's
caribou,
the thought.
I suppose. Yeah, okay.
Now, some colleagues of mine have been looking at the caribou and wolf question with GPS telemetry and so on, but some of the experimental places where they've done, let's say, line blocking with trees and so on.
Yeah.
Also happen to be the places where the government imposed wolf reductions. And so there's no longer wolves on the air, a GPS collared, to see how the wolves respond to the line blocking.
Oh, yeah.
So although they were trying to like see, well, what's the effectiveness of this treatment? And ultimately what they're interested, which is reducing wolves into caribou range and caribou habitat and accessibility in the winter, especially in the winter. Oh shoot! The experiment is screwed up because
there's a wolf call.
There's a wolf call, so it doesn't matter. And so it's like the GOA policy, the government of Alberta policy to implement the wolf call was more important to understanding whether the behavioral use of the lines was more or less.
For sure.
So
well, it makes sense because it seems like the wolf call, although not a solution, a long-term solution, it is temporarily providing the caribou that space to not be as heavily predated, right?
Exactly. It's definitely a short-term solution, and they have to keep on it.
But it has showed to help, right? Like it has.
Yeah, for the most part, it's controversial too, from both an ethical standpoint as well as whether it works. And it can work if they're extremely aggressive. Right. The issue with wolves is you kill a few wolves and they just move in from outside.
Yeah.
Because one pack, the number of pups they have is very large, and they're always sending dispersers out. Mm-hmm. And so if there's an area with game and habitat that doesn't have a wolf pack, that becomes a new territory extremely quickly.
Yeah.
So you have to do it at large scales and very intensively. Yeah. And then for the most part, it's been shown to work. But the issue is it can't be a long-term solution, because the long-term solution is about habitats and seismic lines and restoration of the habitat.
We don't want to have to keep shooting wolves forever, because that's just not. We want this to be a sustainable population without our assistance. That's the goal, right?
Exactly.
Right.
Yeah.
Okay.
And exactly.
Yeah.
And there's the black bear issue too. So if you're doing the cull in the winter when black bears are in the den, you aren't actually getting at the black bear issue.
Right.
So it's.
But I suppose some of that is probably like I imagine there's always been some amount of predation on caribou from black bears and wolves.
Yeah,
there's always some. We're just trying
to
reduce that extra amount that's happened. And
absolutely,
I suppose the the historic norms of predation on those animals is probably, even now, because the population levels are so low. Even if it was just those historic numbers, it would still probably be problematic, I assume. So we're in a weird situation where well, let's get it back to what it was. And it's like, well, what it was right now is still problematic. I've always wondered like if we're trying to, and I hate asking this question because it sounds so like just forget about it, but are caribou, are they maybe a poorly adapted species and it would be for us. Like we've created a new situation where caribou clearly aren't thriving.
Yeah, exactly.
But
they're poor. Honestly, they are poorly adapted to the southern boreal. Mm-hmm. They're poorly adapted to scenarios of, higher diversity of game. To be honest,
they're not resilient.
They're not resilient. Yeah. And I mean, this is we were talking about real briefly about kind of the relic idea. Mm-hmm. They're kind of the relic of the post-glaciation ice age.
That's my thought too, right? Is that they're almost like they went hand in hand with the bison, right?
Yeah.
And the bison that we have now are like very protected, and they're in specific areas, and they're highly regulated. Mm-hmm. And now the caribou is getting to that point where it's like they managed to stay in the shadows for a while because they're not in the plains. They're in the middle of the bush where nobody hangs out in the black spruce and larch swamps.
Yeah.
But now we're like, okay. They're equally as delicate as a species.
Exactly.
Right?
Exactly. Yeah. Yeah. And so I think, some people would say, well, this is real big picture thinking, but it's more like, is it worth the cost? If they're a relic anyway, and the long-term prognosis, even without us, was a slow shift north anyway. Mm-hmm. Then who knows, right? So
that's a big question. Like that's a huge, and I think we'll continue to rage against the dying of the light on that one for as long as we can, right? Until it gets to a point where we go, okay, it's going to cost us, whatever, $1 million a caribou to keep them around. It's like there will be a point at which society will say, no, that's not worth it, and we'll have to let it go. But so hopefully we can curb that and get ahead of this problem. And
absolutely.
With the restoration of seismic lines and that kind of stuff, like I guess one other thing would be new exploration, seismic exploration.
Yep.
does the new methods of seismic exploration have the same issues as, like, are we going through and restoring lines and then just having new ones pop up? Or is it, I know they're using smaller, they're trying to be low disturbance, but what's the research on that?
Well, it's yes and no. So I mean, more recently, last few years, there's less exploration because of the price of oil and so on. But the last number of years, last decade, they've definitely moved to what they call low impact seismic lines. They've already started to refer to this. They've reduced the width to roughly 3 meters, 2.9 meters, 2.8 meters in some instances. And they tend to try to create a wavy line that supposedly breaks line of sight of predators looking down the line. Maybe makes it a little bit less efficient for as a corridor moving down, but the original idea was kind of breaking line of sight, although people question whether that's really effective, especially wolves that may hunt through their nose more than their eyesight.
Sure.
So it was just kind of let's do, if it's easy to do, let's do it.
I always said that, with animals, right? Like you can fool their eyes,
maybe
fool their ears,
but
like,
we don't have very good nose. But other animals, it probably
they
is
always
less,
trust their nose, always trust their nose.
So I'm skeptical of the waviness of the seismic line really being that effective. But they've done different things, and I think the most exciting is called zero impact seismic lines, which they literally don't cut the trees.
Yes, those are the ones I was thinking of. Okay, so those are zero impact.
The zero impact is really new.
So they're not; those aren't even like
there's no footprint whatsoever. So they send crews out with the seismic explosions, or the points with a high resolution GPS to put them in the positions that they need to be.
Right.
And rather than cutting a line and then having these lines really quite specific in their orientation and on a grid, and so it makes it easy for people to go out and do the seismic assessment itself.
Yeah.
Well, they said, well, why not do the seismic assessment without putting lines in first in order to get the people out to do the seismic assessment and put them in very specific places. But with GPS units, you can put them wherever you want. I mean, they were using that before too, but
now it's just an issue of people getting lost.
I guess it's people getting lost, make it harder for the crews out there.
So you have to have much higher skilled crews.
I guess so.
Definitely.
Yeah. But in the long run, think of the cost savings as far as restoration. Now, it turns out I was talking to someone and I was like, well, it must be cost savings because you don't have to cut the trees in the first place. But it turns out that the most expensive part of doing the seismic assessments is actually the computer modeling of the
charges.
From the charges to map the actual reserve. So let's say the bitumen.
I see. So the
computers have to crank to create a 3-dimensional model.
So that's post the actual
the processing of the data itself costs more than collecting the data. And the person I was talking to said, interestingly enough, because those locations are now not on these like perfect lines, or I don't know, it actually costs a little bit. It costs more to do this post-processing, the processing of the data, than it does of the cost of cutting the lines.
Right.
So at this point in time, it actually is a little bit more expensive. It's more expensive than, which seems counterintuitive, but it's less expensive because in the future they won't have to restore it, and presumably the prices would come down.
Well, that's what I was going to say. I was like, I feel like that's not including the ecological and societal costs that the current linear disturbances have on society, because those were never included in the cost of it, right?
Exactly.
It was just like, it was like, cut the line and you could pay a small fee for not restoring it and don't worry about it. But we've since realized that if that fee was a lot higher, which is what would be, it's like the idea of a carbon tax or whatever, right? It's like, we're not paying what the real cost of this resource is.
Exactly.
And if you actually accounted up all of the cost to society of these seismic lines, if you could do that somehow, I don't know, with ecosystem services or whatever, then I think you'd probably realize that the no impact is probably better. But that requires some high level thinking and some very, you know what I mean?
Well, I think it's the next generation for sure. And I think, but the issue is the majority of Alberta that has, high valued energy resources already have a whole bunch of seismic lines on them. So
oh my God, yeah.
It's the opportunity for more isn't as much as it was obviously decades ago. So
you could go onto Google Maps right now, anywhere, and just go to northern Alberta, zoom into the bush, and just count how many lines you see, because there's lines everywhere.
Oh yeah,
lines
and these lower impact lines I was trying to describe before, you tend to have these these traditional legacy seismic lines that were spaced, 200 meters, 500 meters apart, sometimes even more. These low impact lines, which sometimes refer to 3D to get the third dimension of the depth of the reserve really specifically, can be as dense as every 50 meters on a north, south, east, west. And if you add that up, that's actually 40 kilometers of seismic line per square kilometer.
Jesus. Yeah. It's a bit much.
So there's a lot, right? And one of the concerns is the pressure that we may have in the future is referred to as 4D seismic lines, and the fourth dimension is time.
Yeah.
And so actually going back to the seismic lines and redoing the seismic assessment to see how, in this case, let's say bitumen, and let's say in the in situ, this is where they're using it for. In the in situ means that the depth of the bitumen is too deep to surface mine. So they're using wells, pipes, and steam and solvents to melt the bitumen and stuff. Well, the 4D seismic lines is going back to a seismic line, and you may have to redisturb it or at least get back out there and then measure how that bitumen has changed as they're doing the mining.
When technology's changed.
Yeah, when technology's changed, they may have to put in wells at different depths and things like that. So there's a bit of concern that although we have all this footprint out there already, and you'd think that we wouldn't need any more, there could be reasons to go back.
Right.
But now with the zero impact seismic lines, there's a technology for minimizing that ecological footprint.
Yeah. It's interesting to me that it was just kind of, I guess it was societal oversight in that we didn't make it be like, hey, you're an oil and gas exploration company. Sure, yeah, you can do seismic exploration, but you have to restore this period.
Yep, it just wasn't done. So it was an oversight.
Yeah. What was the regulation there? Like, did they? Yeah. So did they have to pay? Was there a fine for not restoring? Was there something?
No, my understanding is they had to pay fees to the FMA holder, the Forest Management Agreement holder,
just for loss of timber.
For loss of timber, and that was it.
So there's no inclusion of actual ecological impact.
No, not originally. And now I think obviously things are changing, but there's restoration and reclamation standards that are being for seismic lines, but I don't believe it's actually legislated. I think these are standards.
Oh, that they take it upon themselves to actually do it.
Yeah. And until the Caribou Range plans and so on are out, and unless there's change in legislation, to my knowledge, you still don't need a reclamation certificate for a seismic line, but you do an exploratory well pad. Or any surface mine, like a coal mine or gravel pit or
that's fascinating.
Surface
That's such an oversight.
Oil sands. Yeah, it was. I think the thought was, you know what? It's just a little narrow disturbance, and it's quote vegetated. I mean, there's still vegetation on it.
Sure, there's
it's
and whatever. Yeah.
It's big deal. There's some vegetation on it. Maybe there's a little bit of timber damage to
just
the
didn't
FMA.
know, eh?
And maybe it'd come back anyway, right?
We just didn't know.
We didn't know. We didn't think ahead to a caribou problem. The fact that they weren't coming back as much as we thought they were, and ecologically, what's the big deal? Well, ecologically, it turns out it is kind of a big deal. For the amount of footprint it is. That's the most interesting thing. Because some of these seismic lines are only like 3 meters wide, you'd think that the total footprint itself isn't substantial, and they may only disturb about 5% of the forest. Mm-hmm. But because they're linear, they represent corridors for movement. Yeah. And so to me, one of the biggest issues is not there's a footprint issue, but it's actually a lot smaller than people think. The bigger issue is these are highways for movement of things that we may not want moving down them.
For sure.
Yeah.
Yeah. Well, when you talk about, like, sure, they're just these small little lines. Don't worry about it. But when you're talking about whatever, a million square kilometers of these lines, right? Like, it's like, oh, okay, maybe
it alters things more than we thought. Yep.
Yeah. And then I don't want to get into a conversation about like who's liable or responsible for paying for this kind of stuff. But it's like, but it does bring up that question, right? Like, who benefited from this? Was there a royalty paid for the loss of societal resource here? If not, then maybe there should have been. And you're not going to go back and retroactively try to get exploration companies to pay for this, because half of them probably went out of business or whatever.
Yeah, exactly.
But it does bring up the question for future seismic exploration, that kind of stuff. Like, this needs to be something that we're definitely on top of, because this is an oversight we can't claim ignorance on anymore.
Yep, we need to get in front of it a bit here and be proactive. And So it's unfortunately some historical decisions were made, and probably at the time they probably didn't feel like a big deal, right?
I'm sure it wasn't. I'm sure it wasn't like this evil.
Yeah,
you know what I mean? Like, yeah, it was just oversight.
Pay the timber damage and go on.
Yeah, because that's at the time that's what we thought was economic importance is the only real thing we need to measure. But now we've realized that clean water and a healthy species richness and biodiversity and all these types of things are we're starting to care now. Yeah, exactly. We're starting to recognize that it was problematic. So, but yeah, it is an interesting problem because now we've got all of this area that needs to be restored somehow or another. It costs a lot of money. Mm-hmm. There was you know what I mean. There was money gained through that, and it's like well, there's some onus on some people, or not some people, on some organizations to maybe step up to the plate. And I'm sure they are. I'm sure they are. Yeah. It's just not probably something that we hear a lot about.
Yeah. So, for instance, in the northeast part of Alberta, the oil sands companies, they a number of them are either individually or grouping together to pool some money for restoration purposes. And so I think that is happening. It's just the scale is very big, right?
Yep.
So and I think
guess who made the scale big?
Well, yeah, exactly. Exactly. And I think there's the companies, but there's also the government, and so without the government stepping in and saying, that this is what it should be like, some policies, it could be it's going to be an ongoing issue.
Anyways, we don't have to get into the politics of it. We can talk more about the actual securing it or whatever. But as far as the actual reclamation of these things, like how there's been a lot of research obviously done through you guys about how much or how successful all of this is, right? So what areas exactly are the areas that you think? So in those areas where, say, the 1/3 area where you think that it's not going to recover on its own up to 50 years from now, and it is of specific importance to caribou habitat.
Yep.
Are those areas showing good response to like mounding and restoration, or is it kind of a lost cause now anyways? Yeah.
We've worked in one area in the Lydia project in the Cold Lake Air Weapons Range with Synovus, and the bottom line is there in the peatlands, the fens and so on, mounding was used and planting of black spruce for the most part, some larch and a few other species, but black spruce primarily. And we looked at that about 3.5 years after treatment. And it turned out for the most part, yes. So they even planted at, I'm trying to think what it was, about 1,000 or 1,400 stems per hectare.
Which is pretty the same what we do for couple lots.
Yeah. But, there's a narrow seismic line, so they do it along that, 3 or 5 meter wide seismic line.
Yeah.
And we went back and counted tree regeneration and trees on those same seismic lines, about 3.5 years later. And we can even draw a line of what that planting stocking rate was. And in many of the different ecosites, the types of fens or bogs it was in, or even doubling or tripling that number because they created the hummocks. They created the mounding.
Perfect hummocks.
So not only did they plant, but then we have natural seed rain coming to natural regeneration on top of the planting.
That's been helpful.
So I would say absolutely.
Okay.
So it is worth it. There's a few, but it's worth it. But we did find a few different type of ecosites where it wasn't necessarily working quite as well.
Okay.
And those were poor fens, it turns out. So a specific type of fen.
Yeah.
You weren't gaining. You were adding some trees, and that the number of trees per hectare were probably maybe in the long term or could work out, but it's a little bit on the lower end. And the hummocks the mounding didn't tend to increase things dramatically with natural recruitment either. So
what are you defining as a poor fen? So is it just like, are we talking mostly black spruce with a light dusting of larch throughout kind of thing?
Very low amounts of larch. So the poor fens would tend to be a little more acidic. So the larch tend to occur in more rich, higher pH type, more basic type peatlands or fens. So these are almost black spruce dominated. Sometimes it may be a little bit more open black spruce where you naturally don't have that many trees anyway.
Okay.
So in those instances, I think it kind of depends on what those restoration targets are.
Sure.
But at least we do know that the cost of the restoration treatments there, you weren't getting as much bang for your buck as all the other eco sites, like the rich fens, the bogs, and we call the transition between the peatland and a little bit of upland, but it tends to be black spruce. We call those poor mesic sites.
Yeah.
And the poor mesic sites, instead of mounding, they actually ripped with a blade or a ripper on the back of actually in the front of the shovel itself, or a different
preparing
attachment.
A seed bed, so the seed has
creating
soil.
A seed bed and then planting, and then that the exposed bare mineral soil also allowed for recruitment and natural regeneration.
Okay,
so there's a couple different types of peatlands, and the type of silviculture used varies a little bit for sure.
Of course, yeah.
But if in the wettest sites, the poor fens and the rich fens and the bogs, those wherever it gets close to the water table, mounding is what they're doing.
Okay,
creating the hummocks. Yeah,
but the rich fens and the bogs in particular are good.
Yeah, they're
advocates for this.
Yes, for those treatments. So at least in that one area during that one experiment, ideally there should be replication of this done in different places and. You never know. Maybe it was the time of planting, or we don't know for sure. So
this is just one. This was
one experiment.
Okay.
It's called the Lydia experiment in the Coal Lake Air Weapons Range.
So more research needed for sure. But,
different places in there. I think some of that is, I'm sure there's other people working on similar projects on it, and I think it'll take a little bit more time, more studies to be confident of those things. But at least a bit of a good news that this was one thing I was concerned about is. If we just go out and just start restoring, in other words, implement restoration before we actually do an experiment on restoration, to know the effectiveness of the restoration treatment, we could be blowing a lot of money. Right?
Yeah.
And it just sometimes you think the restoration is just
caribou might not have.
And you're like, well, it's a potential waste of restoration dollars just to show that you're doing something. But if it's not being done well, what's the point of doing it?
Yeah.
Well, it turns out that at least the sites we were looking at, for the most part, it is working. So I guess 100 years of forestry and silviculture, probably people can say, you could probably use this treatment, will probably work, right?
It's paid off.
It's a little bit different because it's a narrow little gap in the forest, kind of thing, but same principles.
Got a lot of there's a lot of people out there with a lot of experience on how to grow trees.
So exactly. So we're lucky there. And I think that is probably the one thing I just mentioned is gap size. The narrowness of some of these seismic lines we are finding is one of the limitations. So in traditional, a cup block or something big and open, you have plenty of sunlight. But in scenarios where there's a bit more of tall tree cover, especially in a narrow seismic line, those places have light limitations, and light is being a limiting factor in regeneration. Yeah.
So what is the orientation of the lines that is causing which ones are the most likely to succeed? They have enough sonics exposure to sunlight that they can actually be successful.
That's the interesting thing. So it's like it even gets so hyper specific of the orientation of the seismic line. So most seismic lines, they can be at any angle, but for the most part, to keep it simple, they run them east-west on a grid and north-south on a grid.
Right.
And it turns out the east-west lines tend to have more natural regeneration than the north-south lines. And it has a little bit to deal with the sunlight on those lines. So the east-west lines, especially the north side of the line that's getting the south exposure, gets more sunlight, and we see more natural regeneration on those. And the east-west lines has some of that. It tends to be a little bit more on the east side of the line with the late afternoon sun having a little bit more regeneration there. But for the most part, the places we look, east-west lines have a little bit better natural recovery than north-south lines. It has to do with the abiotic environment of sunlight and
it makes sense. Like you think about
things like that.
In the northern hemisphere, you think about an east-west line. Yeah, you're going to have generally in these bogs and stuff and fens and stuff like that, the trees are really low. So you're going to have sunlight basically on the north edge of that line all day long. Whereas the north-south line, you might just have it for a few hours in the middle of the day. And so it makes perfect sense. It's what you would expect.
Get a little, exactly. You get a little window of light at a certain, well, I guess when it lines up perfectly, almost like in the north-south line at noon hour. Yeah. And then other weird angles, but it's very brief at that noon hour.
Yeah. So would you think that it would be important to focus... did you guys do research on that with the restoration as well? Or this is just the natural regeneration?
This was just natural regeneration.
Right.
So we haven't done it on the active restoration where they experimentally, mounded and so on. But in the natural regeneration, we definitely see these patterns of an interaction of line orientation and width. So which comes back to how much light there is. If you're really wide, then that north-south line actually gets enough light that it's promoting natural regeneration on itself.
Yeah.
The east-west line can be a bit narrower and still get enough sunlight to see responding natural regeneration of trees.
Gotcha.
So we do see it's as specific as line width and orientation
It's so
on how much
specific,
natural regeneration you see, and therefore maybe where you'd go or not go with restoration.
Are they just planting black spruce? Or are they planting larch as well?
No, they plant larch as well. I think black spruce is the majority, but larch is in there, and I think on upland sites they even plant jack pine in some places.
For sure, that makes sense.
But
the larch was the interesting one because I was like, I don't know if I know. I'm sure there are larch seed plantations, but I don't know. I'm like, do I know that those? They must exist, but it's because it's something that like if you have the right ecosite for it, then you could plant larch and it's going to grow 10 times faster than black spruce, and you're going to have restoration that much quicker. And but I'm sure the silviculture foresters have thought this one through.
And I'm not sure the seed nurseries and how much maybe that's one of the reasons they just plant less larch is maybe there's less. Nursery growth of larch, or I'm not entirely sure either, but
I don't know.
Black spruce is the predominant, though.
Yeah, there's a lot of that for sure. No, it makes sense. So has there been interest in like with other oil and gas exploration folks? Are they using this, like your research and stuff like that? Are they taking advantage of all the work that you've done and actually applying some of these principles to make sure that it's like this is going to be successful?
Yeah.
You know what I
mean? I mean, yes, broadly, yes. Yeah. I mean, there's a number of groups that are looking at that question of prioritization.
Okay, so they're starting to look into how you guys have decided where is the priority.
And others. And so kind of going back to that first LiDAR modeling we did a number of years ago, Cassidy Van Rensen was a graduate student who did that work in my lab. And the second part of her thesis was, the first one was using LiDAR, where are trees coming back and not coming back on lines? Oh, they're not coming back here. Then she scaled up and did a conservation planning exercise where we actually prioritized restoration based on the likelihood it would come back. Yeah. Or in this case, we'd prioritize places that are less likely to come back.
Right.
And the overall a clumping of lines that won't come back. So it can't be just a little segment because these were little tiny pixels on a line.
Right.
And so she looked at it at that question, then the question of where it overlaps caribou, where it's near roads, those kind of things, and created one of these first prioritization models. And people have since kind of updated similar prioritization models for doing regional planning of where should we go to do seismic line restoration in caribou range.
Right.
So and one of the interesting things is you think, well, you'd want to go to a place where there's as many lines as possible to get your best bang for your buck for the excavator and people out there, but it's actually the opposite. Huh. They're trying to find places in caribou range that have very few lines. So restoring that line has a bigger overall impact on caribou than a bunch of individual lines, because the general policy is you should buffer anthropogenic footprints by 500 meters
which is
for caribou, which is insane, right? Yeah. So if you have a grid spacing of 50 meters of seismic lines, you don't the buffer is bigger than 10 seismic lines put together. So if you just have one seismic line going through bisecting a caribou range, you take that one out by restoring it, you get your best quote restoration amount.
Yeah, there's been some weird math done by some NGOs regarding that like 500 meter buffer. Yeah, that's like it's not necessarily not true. It's just like, well, you're pushing the envelope of that scientific research a bit. Because I can't remember which group it was, but they said there's like, oh, the boreal forest is 97% disturbed or whatever. And you're like, whoa. Yeah. Like to the unknowing public, they're gonna look at that and go, what do you mean? It's all a parking lot? Like what happened? And it's like, no. But the 500
edge
meter
effects or buffers.
The edge effect. But the 500 meters has warrant, and it's for caribou. Particularly, right?
And behavior. So is more, again, coming back to the GPS colored caribou and, how much they hung out near lines. And not quite as much. I mean, they still used them. So that's the thing. There was avoidance, but it was was in a complete avoidance. And even people have talked about there's a difference between a behavioral change in wildlife and a numerical, like a change in the population.
Oh, yeah.
So it's still not clear how it connects to the population, except through wolves. If it's wolves on the seismic line, then there's no buffer. The wolves are using the line. Does that make sense? So it depends on how you define it. If you define it from a behavioral standpoint, maybe there's a 500 meter a bit of avoidance. But just because I alter the behavior doesn't mean it alters my reproductive rate or my survival or anything else, right? So the numerical side, the population side.
Right.
So in some instances, behavioral changes may not translate to numerical population changes. And if that's true, then
they found a correlation.
Then the buffer is it's just purely a behavioral thing. But we do know the seismic lines are corridors for wolves. So
and 500 meters for a wolf. If you're a wolf walking on a seismic line and there's a caribou within 500 meters of you, and you're downwind, you're going to smell it for sure.
Yeah, exactly. So it could even be bigger, but it's I mean they're using the seismic line, but they can smell the scent or pick up on a track, and then it leads to the whole range.
Yeah. No, it's an interesting one. So the 500 meter buffer on the, you know what I mean?
Yeah.
As considered non-caribou habitat.
Yeah, non-caribou habitat, yeah.
It's still not totally set in stone. It's like, that's an interesting number that we should look more into. Okay.
Well, it's not set in stone, especially by the ecologists, but on the policy side, it tends to be a rule that's used for caribou range assessment, disturbance assessment.
Better to be safe than sorry, for sure.
Yeah, they're using exactly. They're better. Exactly. The precautionary principle in conservation is better to be safe than sorry. So for now, use that rule, and maybe it would change with time when ecologists can more formally test how it propagates up to the effect on the population.
Yeah, that makes sense. Cool. So do you have any further kind of, we're working up on hour 15 here. So, what else do you think what other information do you think that people would like to know regarding this research that would be something that would, help them in their, whether they're, forest practitioners or working in the energy industry or whatever. What else can you tell them that would be helpful to?
Yeah. Well, I could, re-paraphrase a few things. One, it's the extreme ends of the gradients of moisture that are problematic, like the driest and the wettest. The driest, jack pine, you wait for a fire. The wettest, fire will help, but in the most extreme locations where the hummocks and the water are lost and the water table is high, those really need the mounding silviculture being done.
That area.
The other thing is, I think the we have the seismic line issue, but it's the cumulative effects of many other things. So I think the seismic lines are the low-hanging fruit and are the things we're concentrating on. But I'm not so confident that alone would so-called save caribou.
Oh, interesting. Okay.
It's because of these other issues we've talked about, being a relic and seismic lines itself aren't necessarily boosting the numbers of white-tailed deer, things like that. It's surrounding uplands of forest harvesting, fires, other things, the complexity, less snow, especially the winter, less snow. All those things are kind of interacting, the cumulative effects of those that kind of create the perfect storm on caribou, and then we go after the seismic line. Well, we probably should.
To point to the big bad corporation,
and it's the easiest one to do because it's a non-permanent footprint, as compared to a road or a active well pad or that kind of thing. So, it's the right thing to do, but it probably isn't going to solve everything in the long term.
Might help though.
It might help, and it may get us. It's in the right direction. So I think that's the main thing. The other thing is, I guess I would say, we talked a lot about caribou because that's the primary issue. But in my lab, we've done other species, other biodiversity, and so Federico Riva is a PhD student of mine, and he did a great job in looking at the story of what's the effect in other species. And one of the groups I wanted to work on was invertebrates, insects, because they operate at a scale that's really, really small. And like a wolf and caribou, like a seismic line is like, they may cross it, they may use it, whatever, they may, corridor or something. But a seismic line is large enough to literally be the habitat of a butterfly, the larval host plant, and so on. And
it's important to point out the importance of looking at those, because I think it's easy. We always love the charismatic megafauna, the grizzly bears, the caribou, but like, what is the importance of those small invertebrates and that kind of stuff to the ecology?
Exactly. And they're good indicators because they respond quickly and they operate at fairly small scales. So that was kind of the logic of doing it. And real quickly, interestingly, he basically found, like, even by the time you got to a 2D or the legacy, the wider seismic lines are about 10 meters wide. Those are the ones he found 4.5 times as many butterflies and double the diversity of butterflies. Yeah. So it actually increased the diversity. And some people say, well, there must have been all these non-native species. And it actually wasn't. It was actually increasing native boreal butterflies. And it turns out in the boreal forest, most of the butterfly species are more dependent on early cereal herbaceous species like sedges, grasses, forbs, clover, these kind of things.
Stuff you don't
those
get
are the
larvae.
You don't get under a dense canopy, especially in peatlands of Labrador tea, those kind of shrubs.
Yeah.
And there are a couple rare species like cranberry blue butterfly is a specialist in peatlands that was sensitive to the oil sands disturbances, but the overall community was basically benefited by these early cereal vegetated communities like seismic lines and well pads.
Yeah.
And then he followed up with a study of, he collected 539 Arctic fritillaries. It's a little bit of a larger butterfly in the mid-late summer. And he did experimental releases where he laid on the ground and released them by hand to look at how they use the corridors. Were they actually corridors for movement?
Right.
And yes, they were. They used them as corridors moving up and down and getting between places. So it's not only increasing the movement of things like wolves, but we find other you'd expect that in other species.
Are the butterflies using it as a corridor because that's where that's what their habitat is? So it's not like they're going to like, let's go leave the habitat and go into this black spruce where I have no habitat. But like,
it's structure and habitat.
It is both. Okay.
So when he released it, they're responding more like a predator after them. So it's what would be most efficient to fly? So he literally laid on the ground. And he released them, and then they tracked how far they went along the line before exiting, and then released them in the forest and compared and things like that. So,
gotcha.
And then he looked at the question of fire refugia. We know that a lot of butterfly species are sensitive if they're larval host plant.
What's fire refugia? Just real quick.
Fire refugia is a little localized piece of ground or forest stand that doesn't burn. So little residual patches of forest.
Yeah.
But you can have anthropogenic, human-derived sources of this fire refugia, and we were wondering whether seismic lines were acting as this, so like fire skips.
Yeah, which you had showed in some of the other...
Yeah. And so in this instance, and this was in the peatlands, the adjacent forest, the duff, the burned duff, which is a way of looking at the fire severity, was 5 times higher right adjacent into the forest compared to on the seismic line.
Right.
So basically the intense fires, this was the Fort McMurray fire, burned right up to the seismic line, kind of whimpered across it.
Yeah.
Sometimes not even burning it, but often burning it, but not very intensively. And then flared up again really hot and basically kept roaring right across the seismic line. But the seismic line itself didn't burn that hot.
Right, so it was a refugia itself.
And it turned out like a lot of larval host plants in the larvae are going to be quite sensitive to fires, almost all the butterflies. So
makes sense.
It makes sense. So you
don't want to burn alive.
These little fire refugia became also little concentrated sources of populations that can basically disperse and reestablish in the adjacent forest, and so it was kind of interesting looking at that, and you kind of looked at the fact that you have 2 disturbances. You have a natural disturbance of fire, and you have this anthropogenic disturbance, but they actually interact in a way that actually could further benefit at least some species and stuff. So that was kind of interesting. And the last thing is we did some plant dispersal studies for invasive plants where we wanted to look at, could they be corridors for movement of weedy plants and things like that. So in this case, we used, we didn't want to use actual weedy plants and introduce weeds on seismic lines. So we did this in upland locations on seismic lines. We used cattails and goose down. And we used a fluorescent water-based dye that we dyed the seed and the goose down, and then we let it naturally disperse off a platform and came back later at night and used a UV light, and we could determine the dispersal distances down the seismic line versus a paired location in the forest. And there we showed the 4 times further dispersal on distance. Dispersal distance was 4 times further on the seismic line than in the forest, which you'd expect because they're wind tunnels and things like that. So we've done a number of other studies. I guess my point would be that it's altering a number of different things. And sometimes there's winners and losers. Like the caribou are a loser. There's probably going to be some winners. Well, I guess wolves and deer would be a winner. But in some instances, even boreal butterflies are tending to respond favorably to it, interestingly. So
that's the interesting part about conservation, right? Is like conservation to me, it's like, I think most people tend to think about it as like, okay, we need to keep things how they are, like keep them like that. And you're like, okay, but what if with climate change and with humans interacting on the landscape in a way that we've never done in history, which is definitely a factor that we need to take account of. It's like, what if this is a new area of, you know what I mean, where there are going to be some species that don't do well here, and there'll be others that take over. So maybe we're in we're in the Anthropocene after all. And it's like, this isn't, you know what I mean? So it's like, is this just part of the natural changeover because we're a natural species just as anything?
Exactly. There's alpine meadows in the Alps that complete plant communities and insects, including butterflies, are completely dependent on the pasturing and maintenance by farmers in the high alpine with their sheep and cows and so on. And they remove them, it shifts the alpine meadow to shrubbier conditions, and you lose some. They literally have species that are only found in those pastures. Anymore. So there's right? So eventually there must have been some other habitats that historically was, but they're lost. Now they're only in those anthropogenic managed habitats. And so if you care about biodiversity, actually you'd want that maintenance of management. I guess you call it. In this case, the management is also gaining a farm product, like cheese or something. But
that's the interesting part, right? Is like I think we want to hold on to what, you know what I mean? We look back into the pre-colonization in North America and we're like, we want that, like what that was. But we're still just figuring out what that actually was. We a lot of people think it was this homogeneous kind of carpet of trees across everything. And now it's starting to come out through, research into indigenous cultural burning and, fire suppression. Like, no, it was probably a lot more of a heterogeneous mix of grasslands to lots of younger stuff it's interesting that I just think it's interesting. We always want to hold on to what we had. And
in that reference condition, usually as Europeans, in North America, we think of that reference condition as being wilderness with no people. But there were people here, indigenous cultures, just like everywhere else on the planet. So if you think of it that way, it's been called wilderness is the myth. There is no wilderness. I mean, there's always been people elsewhere. There's a few people use places less than other places, but historically we've always altered and been around. And if that's the case, then our concept of what we do for restoration can be completely altered, because restoration often requires that we create a reference condition or a goal or target. And usually that involves removing people.
Exactly, right? Which is it's so weird.
Which is kind of contrary to the history of the planet. And human culture and so on. So I think more recently people are changing our ideas around restoration to include people. And
which is wise, considering we're not planning on going anywhere.
Exactly. So some people, there's these 3 R's in conservation. Reservation, which is conservation protected areas, protection, create a national park or something. There's restoration, which traditionally has been what we talked about, like a wilderness myth. You kick people out and you make it to what we thought it was pre-European in North America. And then there's reconciliation ecology, which tries to reconcile the differences between people and our environment to actually build biodiversity in the places we work, live, and play. In other words, we don't separate people from biodiversity or our environment.
Trying to live in harmony with nature.
If we can, or at least try to maximize value in both, right? And so I think, those are kind of the paradigms in conservation. Reservation, the protected areas, restoration. We don't have any more protected areas, but we have a lot of destroyed habitat. We better bring it back. But then we originally were bringing it back to something that was probably, not really true. Or, ignored fundamental issues that people were always here. And then maybe we're just starting to see a bit of this new paradigm of reconciliation ecology of trying to build, allow people to be part of it. So even in some instances, mixing it, we actually have protected areas that leave indigenous cultures, indigenous people in them.
Right.
Because historically we kicked them out.
I know,
like Jasper
right?
National Park, you're out.
That's the craziest example, right? Is like they're living harmoniously with the wildlife and ecology in Jasper National Park and Banff National Park for millennia, for 13,000 years, as far as we know. And they've been living with it and burning it and managing it and living with it, and it was all great. And we're like, hey, out of the interest of conservation, you guys can fuck off. Yeah, it's just like, whoa, what is going on?
And then we
right?
find fire suppression, and we have to fire issues of, they get burns too hot and big, and
it's so fascinating.
Prescribed fires before, and
now we're just like trying to correct all the mistakes that we made as settlers, and trying to get back, and now we're realizing like, oh, sorry, indigenous folk, like we kind of are bad, and then but now there's still a push towards, well, we need to have more parks and we need to have 50% of protected areas in Canada, and you're like, well, what is your definition of protected?
Yeah, exactly.
Do you mean no people?
No people?
Do you mean no fire? Do you mean no, like, what do you mean? Because that's not wilderness. You're creating parks in and of itself are not wilderness. They're their own.
Yeah. They're one tool. I see it as one tool in conservation, and one of our oldest tools. Yeah. But it can't be used as the only tool. So if that's the only tool in your toolbox, we're not going to get very far.
No. Well, yeah, exactly. Yeah. Like, they're good you need to use them for certain things, but they're a man-made ecosystem. Yeah. The same as, you know what I mean? Like, I don't know, a gravel pit. Yeah. Like, it's the same thing. It's just like one is requiring total and complete involvement, and one is trying to totally get rid of involvement and realize that neither of those sides of the spectrums are going to work.
Yeah, and the biggest issue with protected areas is they tend to be highly biased in where they're placed. Yeah. So historically, the national parks, and for the most part continue to this day, are put in places with high recreational value or spectacular. Yeah. But they don't necessarily have the highest biodiversity. Yeah. So there's the areas of highest biodiversity tend to be the places that have the lowest number of protected areas. Yeah. Because they tend to be the most productive habitats, which has the most agriculture. And so there's this whole issue. And in the United States, the areas of highest biodiversity on a per unit area are actually U.S. military bases. Oh. Which are... Just bomb the hell out of it. Well, this is the interesting thing. So they're protected from the standpoint of the public can't go and use them. And they use them for training exercises, which promotes processes like wildfire, because literally the flares start a fire and the bomb starts a fire, or creates open, mineral soil and so on. And it's full of endangered species, more endangered species in U.S. military bases than any other management area in the United States.
Isn't it funny, just like that?
And they've been like that for 100 and some years. So they went from like native habitat to maintaining native habitat, but with these disturbances. But most of those native habitats had disturbances, and the lack of disturbances have lost biodiversity tremendously. Yes, yeah. And so that's the reason they kind of, anyway. So
we're almost ruining it through loving it, right?
Yeah, exactly.
It's a fascinating problem that we've gotten ourselves into, for sure.
Yeah. So we have these anthropogenic habitats, and including these seismic lines. Yeah, some species are doing well. I mean, obviously caribou and those things are going to be the ones that are going to drive the conservation issues in this particular case. But it is interesting knowing the other kind of interactions of species, and we've done a bit of that work. And one last thing is we even looked so far as blueberry production. And this is in more jack pine forests. On seismic lines, blueberry, the abundance of blueberry isn't that different between the forest and the seismic line, but the vigor, like the height of the blueberry, the flowering, and the total fruit production is better. And some of it is because maybe a little more light, but also remember I told you about insects going up and down?
Oh,
so bumblebees are also using those as corridors and then increasing fruit set.
You wouldn't
by
think
pollination,
that. Right? You wouldn't think that insects are using
they're
corridors. Massive corridor.
Yeah, well, but they're food highway, and anyway.
So it's so it's not an all bad thing, but it's just like it depends on, we have to decide what our values are. Yeah, right. Exactly. What are we hoping to have more? So interesting. So from a bumblebee perspective, maybe we want more seismic lines.
But I mean, there are endangered bumblebees, but in the north probably less so. It's caribou, or you're going to manage for the thing that's the most endangered. So,
yeah, for sure. No, it makes sense. Awesome. Any final thoughts? Anything to top it off?
No, I think that's great.
That was a pretty good way to end it off. Some philosophical discussion around what the hell are we actually doing.
Yeah, exactly.
Awesome, man. This is great. Perfect.
Good.
Yeah, good stuff.
Thanks
a lot for listening, guys. I hope you guys enjoyed that. I know I really enjoyed talking to Scott. He knows his stuff. Talking about the caribou problem, it's an interesting issue to discuss. There's so many angles. So I appreciate Scott taking the time to come in, and I hope you guys liked it too. Thanks a lot for listening, guys. If you guys have any questions for myself or Scott, send me an email, yourforestpodcast@gmail.com, and I will definitely get back to you. Take it easy. See you guys next time.